Hello, good morning, good evening, good night. Welcome to another episode of High Performance Delta. I'm really excited today to talk about a project that Robert's been working on that will show just a different way of working with like the Delta Lake ecosystem. And, it's going to be awesome. So today's going to be fun, super well rehearsed. It's going to be awesome for everyone. Robert, do you want to give a little bit of like a kind of introduction to the presentation, to just Arrow Flight SQL in general, and kind of the environment that we're looking at today?
Absolutely, yeah. So hopefully it's going to be fun. Building it is fun. So the thing we're talking about, certainly building it is fun. So I hope we can transfer some of that in the broader ecosystem. But essentially, you all know things like TCP/H, TCP/DS, well-established data generators that have served the community well and actually have some awesome, very modern implementations in, I don't know, there's a Rust implementation that's really fast. Databricks knows how to do this. But what these data generators are built for is to evaluate and assess the quality or the performance of a query engine. So today we're looking at different kinds of systems, right? Today, the query engine still is or sometimes the core part of a platform, but in this agentic world, the data that we get from these sort of established data generators just doesn't suffice anymore. It doesn't suffice because it doesn't kind of feed the systems that we're interested in, right? There's much more different kinds of data that we require. I don't know, unstructured data. Also, let's say what I call environmental data that we may talk about, right? So you gather these signals from your own data estate, but also, I don't know, from the X API, from wherever,
Mhm.
and you build a holistic picture out of that, right? And obviously TCP/H or TCP/DS or other data generators were not designed for this kind of scenario. And also, we're not really interested in testing performance to a degree, but more to experience a platform end to end. And this obviously kind of, one might ask, oh, wow, well, what has this to do with Flight SQL? Well, if you wanna generate data, you need to generate a lot of bytes, and these bytes originate somewhere and need to go somewhere else, right? So they fly over the system, and the question of how do you move data efficiently in such a system without the thing itself becoming like a big data monster that consumes resources to no end is an interesting one. So the data generation problem becomes an interesting engineering problem as well. And this is where Arrow ecosystem and specifically Flight SQL come in to make our life a little bit easier. And we'll also touch about, actually, just to go into the Flight SQL stuff, we'll just touch about an actual implementation of vacuum in Delta to kind of understand why this is interesting, how this works. And then we'll go into the sort of data generator a little bit and see what that does and why Flight SQL and Arrow and DataFusion are interesting technologies there as well.
Yeah. Do you want before getting started, do you want to talk a little bit more about like the importance of stress testing when you think about like these distributed systems that are, distributing now, like no longer, kilobytes in feed or megabytes in feed, right? Like we're talking more about like terabits per second across, things like OpenAI and things like that. So it's like, your ability to serialize and deserialize and send data across the wire is very important. And why would people want to stress test, right? Like for people that haven't done this before.
Yeah, I mean, ultimately, the world out there is dirty, right? So that's something you learn. The production systems, they don't behave like the systems you have in CI/CD, even if you have good tests in Happy Path, right? Once you put load on the systems, I don't know, packets get dropped, connections get lost,
Mhm.
memory gets exhausted, yada, yada, yada. All of this kind of stuff happens, which is hard to kind of build in CI/CD. You need actual load, you need actual variability to see these sort of effects emerging and to get some trust that this works.
Yep.
And this is why you also want to inject erroneous data and kind of mistakes and hiccups in everything. This is a good thing. So actually, in the thing we built, there are some bugs that we're deliberately not fixing because they kind of yield interesting error states for the generated data that you need to be able to deal with. So both in terms of volume and speed, but also in terms of kind of quality, variability of the data, you just need to put your system under stress. And also from this perspective here, if you showcase stuff and it's kind of all Kaggle clean data sets, kind of, nothing against Kaggle, right? So then Kaggle is great and it teaches you a lot of things, but it gets boring after a while, right? So if you want to see interesting data engineering pipeline, if you want to see interesting stuff happening in a platform, data engineers might disagree, but it's more fun to have dirty data than to have clean.
Oh yeah, or even just realistic, right? Like I think there's
realistic is the better term.
Yeah, well, I mean, because there's not a lot of cases where it's like you have like, it's like 8 perfect columns per row that always have exactly what you'd expect within like bounds and things like that. Like you can have that, but it takes a lot of like upfront effort to get to that. But in the real world, a lot of people are crunched by time, and then time becomes like, really the only differentiator between good and dirty, right? It's like, well, we had to get this thing out the door, so sorry, everybody. So it's life.
My bad.
Yeah, oopsie. Awesome. Do you want to pop into the slides and we can kind of walk through like the examples, and we'll just go through and show the world what this looks like as well.
Absolutely, let's do it. So here, I mean, the first thing I need to mention is the title. So in flight over your Delta Lake, I really wanted to call all of this hydrofoil because for some reason I dealt with, I think, the America's Cup or something, and learned that they have these cool fins under those high-tech boats that let you like fly over the water, kind of.
Yeah.
So I thought for Flight SQL, that would have been kind of the perfect name, but we're stuck with this.
We'll get there. We'll get there.
So. We'll get there if this implementation ever exists. And let me stress one point. We'll touch on a lot of very interesting topics today and a lot of implementation that exists. We're not presenting a finished product today. This is more kind of a work in progress, sharing some thoughts. In any case, let's dive right in. So we'll talk about 3 major things. First, Arrow Flight SQL. How does that all kind of fit together, work together, the Arrow ecosystem? We'll go a little bit into the life of a SQL query until we'll kind of examine what does a vacuum command look like when it gets executed over Flight SQL. And we'll also dive into the implementation of this. And then we'll see. So I really had to kind of stay away from too many godlike things like building a universe, stuff like this. But we created a little universe, and we'll talk about what that universe looks like and why it's interesting. All right, the life of a SQL query. Let's start with some Arrow basics. And here, this isn't my picture. It's I stole this from a blog. Kind of the credit is linked down there. But it's interesting to understand kind of the different layers of the Arrow ecosystem, which may not immediately be clear to everyone. So Apache Arrow itself is the in-memory representation of data. And in-memory representation already is very interesting because you may go ahead and take the naive approach. And I always like the dictionary column example, but there's many other examples out there how you can find optimized representations for data. So the dictionary column example is, I don't know, you have area codes, what have you. This is always going to be a finite set of strings that you want to represent. So anytime you have sort of this scenario, you could go ahead and store a string for each individual value in your array, and then sort of lay that flat out, and then you essentially have a vector of strings. But that's kind of the most naive representation of the data. If you go into the columnar world, where we're talking about in a single batch a couple of thousand records, in the terms of processing millions or billions of records, you don't want to carry all this load around, right? So there's representations you can choose, essentially saying, okay, we have this finite vocabulary. Let's just encode it in a dictionary. Let's say USA is 1, I don't know, Germany 2. And all of a sudden, we're no longer storing strings, but we can just store integers, which is much, much finer representation. But during processing, we can still expose kind of the data as if it were a string, right? And Arrow has different kinds, like string views, I don't know, different kinds of optimized representations of data for the in-memory processing. So then there is Arrow Flight. Arrow Flight, and Scott, obviously this is something you like a lot, I would say. So Arrow Flight, in essence, is a definition for a gRPC server. So it's a protobuf spec, actually coupled with a flat buffer spec. So the Arrow data itself, the thing we talked about, like dictionary arrays and stuff, is serialized using something called flat buffer, which is then stored as bytes. But Arrow Flight essentially defines how can you move large amounts of data between systems. And there is the transport layer, which is protobuf, and gRPC, which handles all the communication and negotiation. And on top of this is kind of it's just a protobuf definition, ultimately, that adds a thin layer around how data should be processed. But this only has 4 or 5 methods, I think. There's like a handshake method, a do get, a do put, a do exchange, and a do action. There might be more, but qualitatively, this is kind of what you can do, right? So it's very rough. It's just I want to send you some data. I want to get some data, right? I'll send you something. I'll get something back, or I have this thingy here. Do something with it, which is sort of do action, which is the freest form, because do action just says send it some bytes and the server might know what to do with it.
Yeah, have fun, right?
Yes. So we need more semantics on top of this in order for it to be actual. Well, this is already helpful if you want to use data, but you have to build a lot of stuff on top of this to actually have a working server. And this is where Flight SQL comes in. Flight SQL only uses, so Flight SQL doesn't even define a new service. It's still the Arrow Flight service. There's no additional RPCs as it would be called here, right? But each RPC also contains this message field where the client can send some message to the server that qualifies what you do. And Flight SQL essentially defines those messages, right? So there is the do put, and then there is a message attached to it, or do get, and there's a message attached to it. And it adds semantics to this so that server and client can communicate in a very defined way. Yep. And this is the standard stuff that you would expect from a SQL server. I don't know, prepare statement, execute query, all this goodness, yep. Right?
I was going to say real quick, for people who are like kind of more familiar with, like, say, like the Kafka universe and things like that, that's like the same thing as essentially setting headers, right? I've got headers per message that then can be implemented, and like that becomes like the the exchange between client, server, and anybody else within like a path of transformations, etc. So back to
you. And as you said, right, you just need to agree on it, but without that agreement, you have no harmonization across the ecosystem.
Yep.
But Flight SQL is still very opinionated in the sense of you are using gRPC, all of this, how stuff is implemented on the protocol on the transport level, right? How the exchange between systems works. And this is where ADBC comes in. ADBC, and that's no accident, sounds just like JDBC or ODBC. It's because it's not it's Arrow database connectivity, I think, right? And JDBC would be, I don't know, Java O. I don't even know what the O stands for. But the idea.
I was just say it's just the other one's just object.
Object. All right. But the idea is always the same. Provide a unified client-side API and hide the specifics of kind of the implementation behind it. And this actually goes a long way. So this is not just, okay, you have some driver and something happens, but it contains a lot of knowledge about what a data system looks like, right? So it implements endpoints like, okay, show me what statements you can execute, show me what data types you define, show me, so you can ask the server all of these kind of questions so that generic clients can negotiate this. And Arrow ADBC provides kind of an API very similar to Flight SQL and also very similar to JDBC, ODBC, stuff like this, but all in Arrow native. So JDBC, ODBC are traditionally row-based, so built for the transactional world, and Arrow obviously is columnar, so for the analytics world, and you really want to take advantage of that. And it may be that in the back end, I don't know, you're talking to Postgres, you're still getting something row-based back and need to convert it to columnar. Not ideal, but at least your client doesn't need to care about it. And if there is a switch at some point, I don't know, maybe Postgres exposes a Flight SQL endpoint at some point, who knows? You can just make the switch and stop paying this overhead. I realize we spent already quite some time on this, so we'll speed up a little bit. But I'm excited about Arrow. I don't know. I think Arrow is kind of the pinnacle of how community alignment kind of led to great success, and it was like, yeah, I like this. I want to do this.
I think it's also interesting too, because you think about like, if you think about like being able to send like, you know, just the columns in memory, and like people talk a lot about like, you know, it's like, really, it's like, you know, it's zero transfer buffer, but it's not really, because you're still doing stuff over the wire. But like, you can still kind of talk about that, right? Where it's like, you know, memory layout is the same as a memory layout. We're working with native memory, and there's a lot of optimizations that occur when you don't have to do anything outside of just using native memory like implementations. So it cheapens like serialization, deserialization by a lot, which is why it's also super fast.
Yeah, and I mean, and this is more on the implementation side from Arrow, from in the Rust ecosystem. But once you get kind of performance sensitive, there's this keyword clone, which essentially says create a copy of this. And you learn to be very, very suspicious of every clone statement, because that's potentially you're shoving data around. But with Arrow, it's great because you can just go ahead and clone everything, which makes your life in Rust so much easier. At least there it's completely guilt-free, because at that point it is zero copy. But let's go a little bit further. So this is kind of what we talked about earlier, right? So how does Arrow Flight and again, Flight SQL is built directly on Arrow Flight work. So we have this conversion between row-based and columnar-based data representations. And in ADBC, kind of this is hidden from the client, right? So especially in the analytics world, we really want to serialize data. But to be honest, I found this is not only true if you, like, I mean, for a single row, obviously it doesn't matter. For 10,000 rows, obviously it matters. But I found the threshold is much, much lower than 10,000 rows, where it makes sense to just use some serialization, because all your applications, everybody waits for it. And maybe this is something for a different talk, but I tried it once. How can we kind of do a full Arrow native round trip? So take Parquet, call it Arrow. it's not, but let's ecosystem. load it as arrow into memory, send it as arrow over the wire, load it as arrow in the browser, and then visualize it as arrow. So never leave that encoding, which is an interesting exercise. How you can do this. By the way I got it to work most easily is using Connect APIs. But again, that's for a different day. Different day.
We can do a much longer discussion on that as well. So
yes, exactly. Well, we need to get through this first.
We're doing great. We're doing great.
So let's look a little bit about how a piece of text, your SQL query, becomes data and ultimately your beautiful dashboard. And then let's look into how does that look like. And we'll be looking at some code. Feel free to interrupt me if we're getting too deep, but yeah. So we start off as a text representation, right? You just typed it in your terminal, you typed it in wherever, select star from. This, somebody starts to read this, which is usually, it's a parser, so it tokenizes it. There are some tokens. I was conflicted if I was going to say like abstract syntax tree, whatever, but ultimately your SQL statement gets parsed into something, and we'll see how that gets processed. From this, you create a logical plan. The logical plan is, let's say, pure intent. It still lacks, so I want to read this table, I want to apply this transformation, I want to select this, I want to aggregate across this, blah, 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 but only intent. It doesn't resolve to something physical yet. And with physical, I mean, read these 10 Parquet files, take what you find in there, I don't know, project out these columns. All of this kind of stuff isn't contained in the logical plan just yet. That's the physical plan. So there is a translation step between the logical plan and the physical plan, and then this physical plan gets executed, and this is where you get your data. So I called it a code review. So let's look into, and I'm a little bit scared because this is quite a bit. But we started with the parser, right? So here we have a simple parser, and this is,
hey Robert, do you want to
legible or make it a
little
little
bit just yeah, perfect, cool. Never mind, you read my mind. This is great.
All right. All right, so here, this is the API we're looking at, literally, right? So here's our string. And what we get is a number of statements which are not quite yet logical plans. This is why I struggle with the ask, but if we look at the implementation, this is why I chose tokens. So here, we're just kind of going into this this loop, but this is an interesting function. So this parser, and there's parsers out there, so we don't need to write all the tokenization logic, all of this. But from this, we get something back, right? And here you see our custom keyword, vacuum. Well, it's not custom. It's
we're getting, so from like the channel, we're getting, maybe increase the font up to like maybe 20 or something like that. It's still just showing up too small. Perfect.
Like this?
Yep. And then one other thing too, given that like we're living in a world with like LLMs and tokens, do you want to talk about a token essentially as like, what is that chunk in terms of like, say, like, you know, select star from table?
Yeah. That's, so we're not embedding this and just telling AI, what does this mean, right? Yes. Somebody has to have done it first, and we're at the level where we did it before AI.
Yep.
So select star from table. Select is a token, star is a token, from is a token, table is a token. But they're all different kinds of tokens. So select would be a keyword that we're looking at here, right? So here we're looking at the vacuum keyword, for instance. Then there is expressions it might contain. There might be signs. Table could be just, I don't know, table one, or it could be catalog one dot table one dot schema one. But it could also be double quotes, some cryptic string containing dots and whatever. No. So this parsing is actually really, really hard, but there are some semantics onto how SQL works, and it essentially deconstructs everything and then gives you back sort of the sequence of, okay, here I found a keyword, here I found a table reference. But we'll actually look into what this looks like, because sometimes we'll just tell it, give me this next thing as, which is kind of what happens here, right? So first, okay, we say we swallow the vacuum, but then we want an object name back, right? So we tell it, okay, here, the next thing should be an object name, and object name means something separated by dots usually, which is configurable, by the way. But then you see, we just open this loop because they can be in different orders, the keywords, right? So you can qualify here or there or what have you. So we literally just go in this loop. And whenever we find this keyword in sequence, and some of them require, for instance, the keyword try doesn't mean anything unless it's followed by the word run. If this isn't the case, then we don't know what to do with it. We don't know what try is. We know what a vacuum dry run is, but we don't know what a vacuum dry is. So I need to speed up a little bit, but here, just going back to this, sorry. So we have text, we consumed all the tokens, and we haven't quite yet made a logical plan out of this. We made something in between, like the parse statement out of this. So, and this is what we're returning here, this this vacuum statement, which essentially just contains the information we extract from the SQL string.
Yep.
And I need to hurry up a little bit. I don't know if people find this interesting or not, or if we should go the other route. But I'll just try my best.
Yeah, perfect. I was also going to say, if you want to hand wave over some of the stuff as well,
yeah,
that's okay too.
I will. Here, this is just a logical node. Plans are plans, right? Project is a logical node. Select is a logical node, and here we have our own logical node that does some of this stuff. This then gets into a planner, and this is where it gets really interesting. I think we need to hand wave some of this here, but ultimately the planning involves actually using the query engine and treating the Delta log as a table that we again query to identify the files we want to vacuum. And things like this. And the thing we implement for this is kind of an extension planner. So this extension planner knows how to interpret our logical vacuum node and convert it into a physical node, right? So here you see we get this user-defined node, and what we return is an execution plan. And in DataFusion world, execution plan is kind of the physical stuff. And that's then the thing that gets executed to produce the data.
Yep.
Right.
There's also, I was going to say real quick, I think for people who are coming from like the Spark world, if you've ever used explain and you've taken a look at like explaining like a specific data transformation on a data frame, you'll see the same sort of planning steps as well, where it will essentially read backwards from the end state and show you each kind of transformation along the way, including unresolved logical plans that then become resolved, where it's like, I don't know what this column is. Does a column exist or not? And things like that as well. So it's essentially ensuring that what you want to do can be done on a specific, reference data set, for example.
Exactly. And I mean, one might wonder, and let me see if I find this really quick. One might wonder, what does this have to do with Flight SQL? The problem is Flight SQL has a lot of semantics, but this is even more technical than what we're looking into now. I'll finish this in just 1 second, but Flight SQL just defines all of these kind of endpoints. This is my tables, this is my catalogs. Yeah, it's but ultimately it's just a gRPC server. So it's more interesting to look what happens with the query as you execute it and how all of this is arrow native than it is to actually just go through the various endpoints that get defined. But now let's be finished with this right now. We'll try to get into more colorful stuff later on.
Yep. We also have time for this too. Like, so I think it's important for people to know too. Like, if you think about like the simplicity of just writing select star from table and having that table be something that's existing in object storage somewhere, and then at the end of the day, you get a result back. Like, it feels super simple, and then like you see behind the scenes, right? It's like lifting the curtain, right? It's like, my God, look at all this stuff, right? But it's interesting too, because it's like, in order for something to be consistent, concise, etc., right? Like, there's a lot of work that goes into that to make sure that the planning steps are working as expected, that they've been stress tested and fuzz tested and everything else like that, so that that you can't really break it. Broken stuff in flight's terrible, right? Because it's like debugging a distributed system is much harder than debugging something that's local. And so this stuff is all important too, even if people are, even if not everybody is going to appreciate as much of the code, but it's still good. So,
and I mean, people implicitly sort of trust, if an engine executes SQL, it's doing the right thing, which may or may not be true.
It depends.
Fingers
right?
crossed. And ensuring correctness is really, really hard. And I'm guilty of this as well. People, including me, throw words around like, projection push down, predicate push down. This is when it comes to query optimization. And if query planning can be hard, query optimization is really, really hard, especially if you do join. So the work that these engines do, especially the engines that are able to optimize queries really well, is quite amazing, to be honest. That's
it's the perfect way of describing it too, right? It is amazing, and because it's like, in order to optimize, you have to understand sizing, right? It's like, at what point do I broadcast an entire table if I'm doing a join, or what, at what case do I try and do, parallel, filtering before I actually send data? And a lot of this stuff, like I think about a lot of this like through like the lens of Spark, because I'm biased towards like the Spark execution engine. But with that, like a lot of those steps were kind of like, it was magical from like the Spark 1 to Spark 2 days when, the data frame APIs and everything else first kind of came out, because you could no longer have to worry about whether or not you screwed up your statements. It's like, you had to filter last. It's like, no, we're going to filter first. And making those choices is incredibly effective as well. So,
and I mean, if you look at projects like Comet, I forgot all the names, but there is a bunch of Spark accelerators out there. And interestingly enough, all of them kind of focus on implementing the physical plan, implementing the execution. Nobody really says, let's just go ahead and build something better than, is it Enzyme who does the planning?
Are you talking about,
like build something better in terms of query optimization in the planning phase than Spark? People are like, maybe not.
There was in Spark, there was like, we got Catalyst, and then there's like the Tungsten like optimizer for memory as well.
And I mean, obviously there's projects that tackle the same thing. I mean, DataFusion for one has its own optimization implementations. But when people try to make Spark faster, they're not trying to make a better query plan, because there has incredible engineering been put into this. They're saying, maybe we can beat Java execution. That's what they're actually saying, right?
This becomes a philosophical debate at this point too, right?
But let's not dive into this.
We can get into that later.
Let's go into Casper's universe. So what is Casper's universe? And it's actually hard to say what it is. Ultimately, it's a fun project to work on. But it's also an agent-based data generator for the agentic age. And I really love that name, because when I say I built an agent-based simulator, people get all excited. And then I'm like, but this is like an agent-based model in the traditional sense. where what has been around for decades, where you have agents that interact and you do sort of a simulation based on this. This is not the AI agent yet. There's also AI agents coming up later, but the agent-based simulator is just agent. It's also a playground, so all of this is open, and we'll publicize more where and how to find this. But it's also just a playground where you can test your ideas. And we talked about optimizations. This is not possible today, but ultimately the idea is that this can also work because it emulates a lot of workloads. And I know, Scott, you love talking about compaction strategies, about partitioning strategies.
Yep.
And Delta offers kind of a hook where an engine can say, I know how to optimize, I can do this, I'll give you a great layout for files. And obviously, this is also an interesting optimization problem. And I want to be at a point where I can start playing around with, okay, how can we assess and just play with optimization strategies, not with the intent to beat liquid clustering. I don't want to I don't have that much time on my hand, just to demonstrate how does this work and how does it integrate.
It's like incremental, like steps. It's always great.
Yeah. A showcase of cool technology. Again, this is just fun building. I love building stuff in Rust. It uses Delta RS, it uses DataFusion, it uses Arrow. There is a huge geospatials part in there. And Kyle Barron is probably not listening, but he built like amazing stuff on top of Arrow DataFusion for geospatial, using H3 indexes stuff. An overblown integration test for various Rust data technologies. I mean, you always need to look for synergies in your work, and we also need to make sure Delta RS and other technologies just work as intended, and just putting load on those and seeing if they do, and if they work under a, let's say, high-stress environment is a great integration test. Whether you would put that much effort in integration is a different question. But I'm German. I'm kind of genetically programmed to over-engineer things.
Yeah. Good time.
And it's also a test bed for various algorithms. So when we talk about Casper's universe, we kind of need to talk about two different things. There is Casper's universe, and then there is Casper's Ghost Kitchen. And we'll actually start at the end, which is Casper's Ghost Kitchen. And again, I have to say, this is not all my ideas, right? The development relation teams at Databricks, we just needed sort of a narrative we can use, and Casper's Ghost Kitchen is that narrative. It's a virtual business. I'm not a native speaker, so I wanted to say based on a true story, because that's what you say about movies, not based on true events. Yeah. But
I think
there is
that works. Yeah,
it works. Yeah. Excellent. Yeah. Because I mean, there's ghost kitchens out there operating, and a ghost kitchen is essentially something some restaurant can say, okay, I want to cook food exclusively for the purpose of delivery, and I'll just rent a kitchen space in this ghost kitchen, and it offers sort of peripheral services around it that, well, make your life easier as sort of the operator of these kitchens. So that being said, you operate this kitchen. We have sort of a pseudo implementation of the business operations, and the business operations can be quite complex. And we can showcase certain artifacts. I don't know, dashboards. There's something like called a refund agent that just says, I don't know, should the customer be offered a refund? But in order to decide, should we offer a refund, first of all, you need data to assess this on, right? So you need to know how long did the order take? I don't know, is there something missing? Stuff like this. And also somebody needs to say, I want a refund. And this is where it gets interesting. So how do we create these situations, right? So, and how do we create this in a consistent way that we can say, okay, this person ordered these recipes, they got prepared there, blah, 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 blah. I don't know, this driver picked them up. It took this long. So we want all of this to be nice and consistent and produce beautiful data, but beautiful data you would see, right? If you have if you have your app, right? I don't know. I use Uber Eats sometimes. You see this little icon traveling across streets, right? We want to create this sort of granularity and experience. But how do you do this, right? And the way we do this is we literally just simulate all of it. So there is a representation for each individual person. We just take geodata, put them on a map in a city, usually around Databricks sites, and then we just have. And this is where you can become interested, creative. So we track some properties of people, and then on some heuristics, they make a decision. I want to create an order. I don't want to create an order. I don't know. I want to eat something. And then we simulate the order coming in, and there's recipes attached to each. So they actually go from, I don't know, the workstation to the stove to whatever. Each of these things is simulated. And by the way, the simulation, and this is the agents, right? A kitchen is an agent, a person is an agent in a sense of agent-based simulation. Mm-hmm. But the interesting stuff is all of this, again, because we want to learn stuff about data systems, is mostly implemented as just joins on data. You do a lot of joins, you do a lot of stuff, but you can write all of this complex logic as DataFusion plans and then execute it. It's all Arrow. It's all out there because we want to really hammer bytes out there, right? And be efficient. So the in-memory state is kept like that. So again, agent-based simulation, right? The ancient and the modern ones. The modern ones really come into play when you want to provide feedback and say, okay, create me 50 bad reviews, and then we can send those out and pretend this happened, right? So what is there to see? On the universe side, and I always distinguish those because, again, this is a data processing system that, while not having a lot of data in memory, produces a lot of data, scans a lot of tables, does a lot of back and forth, and it's just interesting in and of itself to see this system behave, right? Already there, you can learn a lot, and it uses Delta Lake, the data lake technologies, right? It uses a Postgres instance, it uses Delta tables, it uses all of these things. It produces streams that are interesting things in data architectures. We do this only for the purpose of generating more data, granted, but we can observe this system. And this is why, by design, this is instrumented using OpenTelemetry. By the way, OpenTelemetry, again, offers an Arrow endpoint because you can just batch in your data, your traces. And this, again, surprise, it's not Flight SQL or Arrow Flight, but it is gRPC protobuf based, how you can send this there. And of course we use this because we like this technology. Yeah. And well, then also, on the Ghost,
I was going to say real quick, like I think for a lot of people who are building like any kind of, you know, when you step outside of like kind of pet projects and things where you're just kind of testing like the basics and you want to go and build something like this, like not having something to go and simulate like kind of a real world. Like a lot of companies, like when I used to work at like Twilio, we would do this for like voice customers where it's like, you know, someone calls and they wait for 15 or 20 seconds and no one ever picks up. It's like, you know, what does this kind of like look like? What's involved with it? Was it because like we could never connect to somebody and things? And you essentially generate as many, you know, possible scenarios. And we used to just call it like, it was like, I can't remember what it was. We had a better name for it, but it was essentially like we had a scenario object type. And for each scenario, you could basically spit out like, you know, thousands of different scenarios under that type, right? So like echo detection, things like that. But going back to this, it's very like, this is an awesome use case as well, even just to showcase all the different, you know, technologies that are available that are needed to then be able to have like a fully operating, like real production system. So
yes, absolutely. Absolutely. So let's look a little bit on what that looks like. And again, why are we talking about this in the Flight SQL kind of talk, right? Because our main concern is how do we move data as quickly as possible and just keep punching at it at a high pace. So we have our universe. First of all, the universe requires road networks data. This actually was the most interesting problem because in order to create, so we wanted the people to actually follow the streets because people go crazy for geospatial visualizations. If you make stuff move across roads and back, I enjoy it. So that's why I understand why others enjoy it.
Mhm.
So we needed this data to not, okay, don't drive through houses. It needed to look good. But in order to make a proper planning, like, okay, I need to go from here to here, we actually needed to pull in quite a bit of advanced technologies. So there is actual routing algorithms that do kind of shorted path searches on OpenStreetMap node data based on whether you use a bike or a car or whatever. Again, overblown integration test. But this is one of the examples. People might use this to just say, okay, let's test how well my routing algorithm is, because simulating the drive actually isn't that hard anymore. You just predefine all the routes. But yeah, if people want to test their routing algorithms, they could do this in something like this as well and see, okay, how well does it perform in the simulation? You have a population we need to track, right? So there's people, and people right now, they don't do much. They either do nothing, or they order something and wait for food, or they eat food, or they complain or praise food, or they do nothing.
That sounds like most people, right? It's pretty much all we do. So it's okay.
Yes. And they also sleep sometimes.
Yeah.
Only very few people order during the night. There's things. Things are the kitchens, the stoves, the sites, whatever. But here, this is another thing I could talk a couple hours about. I don't know if you know the Facebook Tao system, like how they model their social graph, which is essentially just two lists, nodes and edges. But I found this model for cases like this very powerful. And we have snapshots because we want to be able to resume stuff. So everything that's in flight, which order line is being processed, in which kitchen, at which station, all of this is kept in memory. Which driver is on which bike going to which location, we need to be able to save this and pick it back up. So all of this is in there, and this produces an event stream. And this event stream is order got created, order got assigned to kitchen. Menu item 1 got assigned to station 1, blah, 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 station 1 finished. A very fine granular thing. And why do we do it this way? When we create an order created event, I said we want to create all of this rich ecosystem data. But at this point, we don't do this. We just say, in the world, something happened. And then downstream, someone might decide and pick up this stream and just do stuff with it and say, okay, when I create an order, they usually do this, I don't know, via our app. So we can generate OpenTelemetry traces that look like you were using the app. We can, I don't know, generate what have you. But by just saying this event happened, we can decouple our simulation from the data it should emit. And also the kinds of stuff it should emit, right? We maybe want to create PDFs for invoices, for ordering stuff. I don't know, right? And we want to have all of this data and produce it. But we do this by just generating the events and then letting someone interpret the events and say, yes, this in a real world would produce this trace of data across maybe even a time span. Right.
Yeah.
So
I was gonna also say real quick. I'm like real quick, but we have the 10 minutes left, but also we can ignore the 10 minutes and also talk about this. Like, I think it's interesting because a lot of people, when you're creating like an analytical, like, you know, you think about like event sourcing, anything else like that, or you think about like clickstream, like it's very important to think about these things in terms of like these generic like events that have occurred. The only way for it to occur is for another event to trigger that action to actually have happened. And it saves a lot of like it's like, well, you know, it's like, I don't know how this happened, or, you know, we did different events from different systems, but it's interesting that you're taking this approach here as well, because this is a really good one. Like in like e-commerce and stuff, you have like a core buy flow. core buy flow is essentially like, we know that somebody put something in a cart and they purchased it, and now an order has occurred and there's going to be a refund if they don't get it and things like that. But it's all states. And so you're just talking about states right now. And you're like, well, we can work backwards from states, but we can't work backwards from ambiguity. I think it's just very interesting. So
absolutely. So again, the simulator itself, to me, is a very interesting thing to look at, right? It's an interesting engineering problem in and of itself. Hopefully the data that it produces is also interesting. But here, there is just, we touched on this, right? You can give feedback twice. Sorry about this.
Yeah.
But ultimately, this event stream, so we can also implement the other side, right? We can provide a pseudo implementation of the Casper's APIs and then actually make APIs requests against that. Say, okay, an order got created. Okay, this created these open traces. And someone made a request against that endpoint and that endpoint. And we can just make those requests and just put them at this endpoint. And then there obviously is kind of the streaming technology. So we want to source, I don't know, we want to track the drivers, right? We want to simulate how it looks like to do live tracking. So we can just send events to an event endpoint, say ping, 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 drivers here, drivers here, drivers here. All of these events we can generate. And then also based on your needs and how much you're willing to pay, because processing all of this is not necessarily going to be cheap if you scale this up. You have the option to scale this down and say, well, but my use case actually only cares about what we do with the Postgres. So I don't want to operate the rest. So the idea is to keep this flexible.
Yep.
All right. I think in the interest of time, maybe I'll just show one thing really quick, two things. And then we're hopefully done. So first, I think the quickest way to show this right now, without going too deep, is let's execute this little test here. So this just shows essentially what's happening, right? So here at every step, and each is sort of a minute, you see these events. I don't know, order got created, order line step finished, order line updated, yada, 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 yada. All of this kind of stuff happens. And the way we want to work with this, and this is not fully hooked up yet, but here you get sort of this control panel. You click something. This is vibe coded, right? But it'll be connected. So here, these orders, these events happen, right? And this is more just a visual way to see, okay, how can this interact? And then you should be able to say, yes, I want really, really annoyed customers that are overly critical. And see, one thing that I felt reminded of is Game of Life. I don't know if you're familiar with Game of Life.
Yes.
For those who aren't, it's a very simple game grid, just a grid. Very simple rules, I think 3 or 4. I don't know. If there's 3 neighbors, you die, or well, not you as the user, but this cell kind of.
This is a different Game of Life that I'm familiar with. I'm familiar with I think it's like the Parker Brothers one. That's a little bit different. But continue. This is interesting.
So this is the computer science problem, kind of. Actually, this is the great thing about Conway's Game of Life. Yeah, this is just a simulation. I don't think they have like the good ones set up, but this happens based on rules, right? Individual cell lives or die. And when you create specific starting conditions, the most amazing kind of structures just emerge from very, very simple rules, right? This is the rules. That's it. And if you look at the videos, there is awesome actual almost machines, kind of like stuff that shoots things out that people build on this. But the lesson is simple interactions can create very interesting effects. And this is exactly what we try to do here. We made the simulation so fine granular and introduce randomness and feedback loops so that interesting stuff can happen without us actually having to implement kind of a lot of complex decision logic. Just by saying, introducing interactions with some known effects like offsets, delays, stuff like this will produce interesting stuff. You can see congestion, you can see, I don't know, all of this. And then you say, okay, if people get their orders too bad, then they start disliking the brand and just, so you create those loops. And this is how interesting stuff can kind of start to emerge
I
out of it.
It's interesting because it reminds me of like the experience of like early on playing SimCity, where it's like, what happens if like disease, overcome, like, takes over your civilization, or,
Yes.
if people are like, well, we don't like you, we are going to eject you as like the mayor and we're going to, rebel and things like that. Like all those kind of randomized like scenarios that, like I think as a kid, I was playing that on like a Windows NT machine. And it's like, you don't need a lot of memory to be able to do a lot of those, simulations. But it's also just interesting in general, like the capabilities of, what you can do when you're kind of composing a lot of small things together, right? It's like, it's interesting.
Absolutely. So in short, we're moving all of this data, and this was a bit tangential to Flight SQL, I admit, but it tells you why it is important and interesting to employ these technologies if you just want to shove data around really quickly, really efficiently. And this is kind of, we don't have time to go into this, but the development experience these days is awesome. It's just fun to work with these technologies because a lot of this stack has matured. And I don't know, protobuf, since buff is there, I used to spend hours setting all of this up, blah, blah, blah. Today is, okay, I'll just write a couple more files. And anybody else also can use it, right? So this is just a lot of fun.
I think that's interesting too, because like you have like, you think about like there's certain things that are like before you were tied to a specific language, right? And you have things like protocol buffers that allow you to essentially be idiomatic in any language that you choose to work in, while representing the same kind of data transfer across the board, which is very important for systems like this, where you don't want to like reinvent the wheel. It's like, well, this is our Python implementation. Here's our Java, here's our Rust, here's XYZ. They're all different. We hope they work together, right? It's like, rather you want to actually have something that does work across the board, especially when you're putting this kind of, this type of like, like energy into building like, these universal world type simulations, and or even just having fun with this. Cause like, it's interesting, like this amount of work is essentially like, it would be a couple steps more to just create a video game, right? Like you have essentially simulated this entire SimCity, right? And it's like, you've got this, the angry patrons and the happy patrons and like, all sorts of things. But it's interesting because it's like, as a very kind of abstract way of looking at this, it's no different than kind of putting together like, a Bomberman simulation, like not as a bad way. There's a video game from Hudson Soft back in the day, which was fun for children, not, terrorism. So going back to this, right, it's like, those video games, like I remember like putting together like Zelda when I used to work at Yahoo Games. It's like, well, Zelda was a fun game for me as a kid. I understand the rules of that game. Therefore, I can put it together and understand how these things work. And I think that's really important as well, because like I think almost everybody who's watching this right now has ordered something on like a DoorDash or some sort of delivery service and has had a good or a bad experience, right? And I think nowadays too, like people are also, by the time a customer has complained in a lot of cases, it's already, kind of poisoned a brand. And so being able to think about like, well, at what point do we automatically send, $4 off your next order or something? We know that this thing is delayed by a certain amount of time. Like feedback is very important too. And, being able to simulate like logistics and, routing problems when traffic and congestion occurs, or, it's a random snowstorm now that had occurred out of nowhere, but the order was placed before the heavy snow. What happens, right? Like you can't cancel the order, but also you still have to worry about like the safety of the drivers. And it's just like, there's all sorts of things that then become additional kind of parameters that will slow or speed up a delivery as well, if you want to continue to just, evolve this simulation, right? It's kind of like that game, I think it was Spore back in the day or something like that, where it's like you start off as like a germ and then you continue to subdivide until you're a world, and these things are amazing. So
yeah. And I mean, this is why I need this to be successful and people to find it interesting, both within Databricks, but also in the outside world. So hopefully we'll find as we kind of publish some more of this today. Don't use it yet, yeah. Let's. But hopefully it gets interesting now, because then, if it's relevant to people, we can start building these sort of things. We can actually start to introduce weather data, because it's all out there, right? There's weather data out there. You could call some APIs, but we don't even need to call APIs. We can just fake it. That's the great news, right? We can just say, okay, now there's a snowstorm based on some probability in time of year, whatever, right? Who cares how we generate this? We just want it to be interesting and to tell some story.
I think it's also we're running out of time, but I think that you're onto this is a very interesting conversation now. It's like almost like it's becoming sort of like, it's how do you build something that is simple that, expresses complexity? Because a lot of times, like if you think about like, well, you're going to connect to like, any of like the National Geographic or like whatever, like it's like NGS. I can't remember like the actual acronyms. I'm going to blame it on dyslexia, but also like, short-term memory loss, right? But like if I want to go and look at like, any of like GIS data or anything else like that, or take a look at like weather or fire data, things like that in like the United States, like there's open APIs for all of that to go and be able to get that data. But a lot of times it's complex to go get that versus just being like, okay, it's 65 degrees Fahrenheit, blah, blah, blah. It's not, it's a great clear day, right? Like a lot of times when people take a look at like probability theory, it's usually like, what's the probability of needing, an umbrella on a certain day based on, what about the weather for the day in the morning, right? It's like, well, if it's, it's a sunny day and it's a clear sky, chances are it's not going to rain. If it's cloudy in the morning and like, it's high humidity, like there's all those other factors. But going back to just an enumeration, right? It's like, it's raining, not raining. Okay, cool. Snowing, not snowing, right? It's like very simple to think about expressing things in a very, it's a binary representation, right? It's either is or isn't. It's much easier also for stream processing because you're not sending over like all this kind of bloat data that doesn't necessarily matter, right? And so it's just an interesting concept. So,
Absolutely. So quick question. I don't know. Do we have still some time for questions? I know we're at time.
Yeah, I think there's one question we could take real quick. So this came from Anwar, and it's essentially like, what about like integrations? And this is going back to like the Flight SQL representation that you were showing early on. Like, is there going to be like an API for it? And at what point would it be?
We'll see. What do I mean by that? So one thing, the simulation itself will have an API. There will be a kind of command and control thing, probably a server that you can send it to. So we'll have the API, and we'll have the UI that we see, and we'll have the server. I also let's take the order creation logic, but also routing logic and stuff like this is actually just UDFs. So I'm trying to build in a way that you can build your own UDF, you get your defined set of input data and stuff you can access, and then you just implement whatever you want to your heart's content. So there should be extension points also internally where people can start to experiment and hopefully do fun little projects, right? Build the next greatest routing algorithm that just outperforms any other routing algorithm. I don't know, right? So we'll see based on if people actually care. But if they do, I'm more than happy to put in the work.
Awesome. Perfect. Well, I think with that, we will leave it from there. We'll leave it there, right? So if there's any other questions, feel free to ask those questions like in any of the channels that you're watching on right now, and we'll get back to you. Otherwise, like I think we'll do like a follow-up session as well and see where things are going, and do other tie-ins and things like that in the future as well. So